we're going to talk about longitude. Remember, the last time we spoke, we talked about latitude. Latitude involves um, it involves the lines that you see here. Each one of these is a line of latitude. And the most important line of latitude that we oriented on was called the equator. Now we're going to look at a different set of lines running vertically on the Earth, and these are called lines of longitude. And once again, here you can see the various lines of longitude, and right here you see the most important line of longitude, the prime meridian. It works just like the equator did, as the line that orients us. So if we look over here and we see something, there's our prime meridian, and we're going to see that now when we look over here, we have a 20 over here and a 20 over here. This 20 to the right is east longitude, and the 20 to the left of the prime meridian is going to be west longitude. So let's just mark that for a second. This side is west, and this side is east. And of course, this line right down, this line right down through there is going to be the most important one, the prime meridian. If we use the prime meridian, we create two hemispheres. So we're going to get an eastern hemisphere here, and we're going to get a western hemisphere over here. Remember, we had done the same thing. We had used our equator to create a northern hemisphere and a southern hemisphere when we were talking about latitude. So it depends upon which orienting line you're using, what type of hemisphere you get. If you use latitude, you get a north and a south. If you use longitude, then you're going to cut the Earth into an east and a western hemisphere. Let's talk for a moment about how we get these lines of longitude on the surface of the Earth. These lines of longitude are going to run from the South Pole to the North Pole. Okay? So they're going to run like this, from north to south. But the way we're going to actually draw them on the Earth is we're going to take our protractor here, and we're going to lay that protractor down on the give me a second here, I want to lock this. Okay, we're going to lay the protractor down here. We're going to move the protractor over here, and we've got to spin the protractor around so it lays like this. And then you can begin to see the degrees as they come out there. And as we mark each one of those, then we move straight up to the North Pole, straight down to the South Pole, and we get longitude. So when we're done doing this, we end up with a globe that has these lines running across it. And we've actually turned the globe, if we were to follow those lines, we would be turning the globe into what would look like orange sections almost. Time to take latitude and longitude and mix them together. And here on this globe, you can see that we've done that. We have our lines of latitude, and there's the equator. Okay, just remember, here's going to be the equator. Here's the equator right here. That's for our lines of latitude. And for our lines of longitude, here's our orienting line, the prime meridian. So we get a set of what look like boxes, although the boxes aren't perfectly square because the Earth is a sphere. And by the way, the reason why the North Pole is up here, is right up here, and the South Pole is way down here, instead of being just straight up and down, is because the Earth always is at a 23-degree tilt. 23-degree tilt. Its axis is 23 degrees from being straight up and down, from pole to pole. And that, of course, gives us the seasons, as we've talked about. But the 23-degree tilt is represented by the tilt you see in the globe here. Once we take both the latitude and the longitude and we add them together, we end up with a place where they intersect each other, and that is called a coordinate. And if you look here, right here is a coordinate. There's an X with a dot there, and it shows a spot where a latitude line and a longitude line have run together, and they have created a coordinate. When we worked with our protractor, we saw that we were creating degrees represented by the little sign like that over top of a number, that being 10 degrees. But we also realized that every time we had lines that represented degrees, we could divide that. We could subdivide that. And so between each line of degrees are 60 lines, smaller lines, that are called minutes. And actually, if we take and put a minute here, and we use this, and a minute here, we can do the same thing, and we can put 60 more lines that further subdivide it, and they're called seconds. So, we get very precise intersections of lines. Let's look down here at the example down here, the Empire State Building. Here we have 40 minutes. I'm sorry, scratch that. Here we have 40 degrees, 44 minutes, and 54 seconds. That's our latitude. That's a line going this direction. Now we want to look at our longitude, the line going this direction. So here we have what says negative. That would be the same thing as west. Okay? We have a negative 73 degrees. And so all of this is a negative number. 59 minutes and 4 seconds. This is the coordinate for the Empire State Building in New York City. We've been talking about position, and that's what all this latitude and longitude has been about. And the thing you have to remember is there are two types of position. One is absolute. Okay? So here we go. We've got an absolute position here. That's because we have coordinates. And this X that we saw right over here is an example of an absolute position. One and only one thing can be located at these coordinates. One and only one can be at these coordinates. All right, give yourself a little chance to work with this. Here's a little project you can do. You can use Google Earth and you can type in the actual street location for Broad Ripple High School. And Google Earth will help you find the coordinates for Broad Ripple High School. So go ahead and see if you can't use Google Earth and find what these are.